For these questions, we're looking for the solution to the equation x cubed plus 6x is equal to 81. We already know, as we've been told, that the solution lies somewhere between 3 and 4. We want to work out using trial and improvement, which is exactly what it sounds like. We're going to try something. If it doesn't work, we're going to use an improved answer. We're going to keep trying to find the solution to one decimal place. So whenever you see trial and improvement, the first thing you need to be doing is drawing this table. You need to be telling yourself what x value you're going to try, the equation you're going to be putting it into, and the verdict, what your thoughts are at the end. I always like as well just to tell myself what my goal is. My goal is 81. That allows me to keep referring back to that quite nicely in my table. So, as we know, the value is between 3 and 4. We can start exactly between that. Halfway between 3 and 4 is 3.5. So, for each of these, as these are calculator questions, I'm going to fill this in with my x value of 3.5, find an answer, and decide whether it is bigger, smaller, or would give me 81. So, I'm going to get 3.5 cubed, add 6 times 3.5. I'm putting 3.5 in a bracket next to 6 rather than writing the multiplication sign, because this is how I would actually go about typing it into my calculator. By writing it like this, it means that when you are typing it into your calculator, you're not going to make a mistake. You're going to type it in exactly as you're writing it, which will make things a little bit easier for you. You don't have to keep thinking back. Also, by putting the bracket in, it means that we can just replace the numbers on the calculator very quickly. So when I type that into my calculator, it actually gives me a value, which I'm just going to put in this line as well, of 63.875. Now I've got to compare that to my goal. My goal is 81, so this is smaller than 81. Smaller than 81 or too small or just smaller will allow me to see, or any examiner to see exactly what you mean. You know it's smaller than 81, so it is not our goal. It is not what we're looking for. So if 3.5 is too small, the next number we need to try needs to be larger than 3.5. I would argue 63 is quite a lot smaller than 81, so I'm actually going to make a little bit of a jump here. You don't have to make any jumps. You can try every number, but sometimes you might have to work backwards if you make a jump. So maybe if you jump too high, you would then maybe have to go back a step, but that's okay. But be careful if you are making these jumps. If you do, be sensible with them. So rather than jump to maybe, 3.9 straight away, I'm just going to jump up a little bit. So I'm going to go to 3.7. If this is then too big, I'll try 3.6. It doesn't matter if your x values jump around a little bit, as long as they're sensible and within our range. There's nothing wrong with that. Just be mindful of the time you spend on this question. So this time I'm going to get 3.7 cubed, add 6 times 3.7. That's going to give me an answer when I type it into the calculator of 72.853. So my jump was quite sensible. I haven't gone straight above. It's been quite sensible. It's worked for me here. That's still smaller than 81. So the next thing I need to look for, if 3.7 is too small, I need to go bigger. I'm going to try 3.8. I'm going to not make too many jumps now, as I'm getting closer to 4. Making a big jump could be quite silly, so I'm going to make sure I'm being a little bit more sensible with this. So 3.8 cubed, add 6 times 3.8. That's going to give me an answer of 77.672. That is still smaller than 81. So the next number I would try naturally is going to be 3.9. So I'm going to do 3.9 cubed, add 6 times 3.9. Which actually gives me an answer of 82.716. As 82 is bigger now than 81, I know my answer to one decimal place must lie somewhere between these two values. So, once again, if I know it lies between two values, you go straight for the middle. So, the next one I'm going to try is 3.85. Because I want it to 1 decimal place, I have to know whether it would round to 3.8 or 3.9, because we know that when we have our number line, if I have 3.8, 3.9 and 3.85, if 3.85 is too big, then my answer must sit in this bit, which would round to 3.8. If my solution, when I do 3.85 is too big, too small rather, my solution must live here between 3.85 and which would round up to 3.9 to 1 decimal place. We know 3.85 itself would round up to 3.9. So by doing this, it allows us to really accurately choose which one it would round to. So just by trying the middle, it tells us which side we need to be on. So I'm going to get 3.85 cubed, add 6 times 3.85, which is going to give me an answer of 0.166, which is too small. Because it's smaller than 81. So, as this is smaller than 81, we haven't quite reached 81 yet. So my answer must be larger than 3.85. If my answer is larger than 3.85 to 1 decimal place, our answer is 3.9 to 1 decimal place. If it was too big, we know the number would have had to be smaller, so it would have rounded to 3.9. Take a look at the methods used here. Remember, these are calculator questions. You are not required to be able to do 3.85 cubed. You are required to be able to type that into a calculator. You are, however, going to need to make sure you are happy with your rounding facts and your skills requiring that as well.